Hello everyone, welcome. Now that we're starting the second half of the course and we're going to be getting into classes and writing programs, I thought I would take a few moments and introduce some of the stuff this week about exceptions and file I/O, text sequential file I/O, and also say a few words about the lab. From here on out, we will mostly be specifying the names of the classes we write. Up to now, I haven't really cared about what you call your classes, but starting probably next week, I don't remember if this week specifies the exact class names or not, but you'll be told, write a class Sophie or something like that. And you have to write the class you have to write that class name exactly as it's specified. And you have to have the methods and their names and their signatures and their return types exactly as specified. I'm going to be using software to run and check your programs. And if your programs, if your classes aren't called exactly what my software expects, my software says that your class doesn't work or doesn't exist. So be very, very careful about that. Keep everything in the default package, which means right under the source folder, no com.company or anything like that packages. Your classes should not have a package statement at the top since we're using the default package. So be very, very careful. We're starting to tighten the constraints, which is how software is written. Two people's software cannot communicate and interface with each other unless the names and all the expectations are met perfectly. So we're getting into that arena now, starting to write more program level things. And one word for the lab. There's a lot of string processing. Using equals equals to compare strings will not work. And also one note when inputting the lab's mathematical expression, 2 + 5 or something, make sure you have spaces between the first number and the operator, and then the operator and the second number. That will make parsing that string much easier with a scanner. So now a few words about text I/O. We've been doing text file input output all semester. A keyboard to Java, and in fact, going back to Ken Thompson's Unix back in the early 70s, a keyboard is a streaming text file. It's just got a really slow access to it. And a console for the output, system.out, is just kind of a weird output text stream. So the scanner you've been working with all semester is the same scanner we'll be using to read text files or things across the web. And the print writer you'll be using to print stuff into a text file is very, very, very similar to system.out. It's technically not the same thing, but pretty much anything you can do with system.out, print line, and so forth. They also exist in exactly the same way, work exactly the same way as print writer and system.out. And one other word of warning, a try-catch block is not an acceptable way to avoid an if statement. I know there are some times when it gets kind of fuzzy about which you should do, but try-catches for exceptions. If statements are for making decisions about how you want your program to execute. Now, one thing that we have not covered yet, we're taking this chapter a bit out of sequence. And we will be covering inheritance in this course in a few weeks, but we haven't covered it yet. But you will see some things based on inheritance. So let me try to give you the Cliff Notes version of what's going on with inheritance. Inheritance is a way that we can get code for free. So hopefully you can see this. This is the chart from a few weeks from now. And what we see is that we have a class, and we've been writing classes all semester. And we've had methods in our classes. Now they've been static methods up to this point. And shortly, very shortly, we'll be putting instance methods in. But let's just hold off. The method is a method at some degree. And so I have this class geometric object, and it has some methods in it, and it turns out it has some data in it too. But again, we won't worry about that at the moment. And here I have a circle, and I can say that a circle is a subclass of geometric object. The terminology gets kind of well, it's precise, but there's a lot of terminology here. We could say that a geometric object is a superclass to the circle. A circle is a subclass to a geometric object. Instead of calling it superclass, I can call it parent. And I can also call it a base class. And instead of a circle being a subclass, I can call it a child of geometric object, or I can call it a derived class of geometric object. All those terms mean exactly the same thing. Superclass, base class, parent, subclass, child, derived class. All those sets of terminology mean exactly the same thing. Don't get thrown, be confused by them. So what happens here is that circle gets everything in geometric object for free. And I'll show you how we specify that in just a moment. But again, rectangle gets everything in geometric object for free. And so exceptions use that heavily. Now let me see if I can show you how we specify that. Here is a little bit of code. I have a class called Labrador, and Labrador is a subclass of dog. And on the class header here on line 10, if I want Labrador to get everything that's in the dog class for free, I say Labrador extends dog. This is the Java keyword extends, and dog is the class that is going to be the superclass for Labrador. That's all you need to do in Java to set up a parent-child superclass subclass relationship. So on circles class header, I would say public class circle extends geometric object. So that's how that works. And as I said, exceptions are based on class hierarchy. And this is a chart from this week's PowerPoint deck. And so all exceptions extend either directly or indirectly a class called throwable. And if you want to throw something, it's got to be a subclass of throwable. And throwable in Java terms has two direct subclasses. One's called exception and one's called error. Now, there are two basic types of exceptions and you can see they are indicated here by the shading. There are unchecked exceptions and there are checked exceptions. And the difference is that a checked exception needs the programmer to do one of two things if it can be thrown in the code underneath. The programmer must deal with the exception using a try-catch, or it must pass the buck on that exception, and that's with the throws clause on the method header. And these shaded classes here on this chart are the unchecked exceptions. So if I'm writing code, these others are checked exceptions. If I'm writing code that can possibly have a class not found exception thrown in it, the compiler is going to force me to either do a try catch or pass the buck with a throws clause on my method header. For these unchecked exceptions, the compiler does not make me deal or throw it to someone else or pass the buck to someone else. By default, the compiler will just pass the buck up my call stack, looking for somebody who has a try catch to catch one of these unchecked exceptions. If there is no such try catch, my main method will throw it into the Java virtual machine, which takes a very dim view of my program and will terminate my program at that point. And you've probably seen this with null pointer or arithmetic exception or array out of bounds already. Most of us have seen that already. So the only difference between checked and unchecked exceptions is unchecked exceptions, the compiler doesn't make me deal with it with a try catch or pass the buck with the throws. Checked exceptions, the compiler is going to make me do one of two things. Let's see, what else? If I want to create my own checked exceptions, maybe I would extend exception or class not found exception. And what that would look like is I would have my own class name here where there's Labrador, and I would put extends exception or class not found exception or something like that. And the throws object, throws clause I was talking about would go here on a class header, throws some exception. I would have to give it the class name. Notice this is plural. The throw statement is throw, singular, exception. The throws clause on a method header is with the S. It's throws something. Careful about that. And let's see. Wanted to talk with you about these exceptions are just classes, and we've dealt with classes before. You can look up just about any class here. If you want to find out Oracle's Java documentation, and Java's the best documented language I've ever seen, just Google, say, Oracle Java 11 API and give it the class name you want to look up, and it will almost certainly be the first thing you come to. And here we can see that public class exception extends throwable, and it has constructors and so forth. Just like Scanner, has, and a lot of very good documentation, a lot of different constructors and a bunch of different methods, exceptions and throwable and class not found exception or file not found exception, all have methods on them too, just like Scanner, just like string. In section 12.4.4, the book lists some of the methods of an exception, and you would use those just like you would use the methods on a scanner or the methods on a string. Fundamentally, same mechanism. So I hope this helps a little bit as we launch into writing more programs and doing more file I/O and so forth. Put your questions in the collaboration forum, and we will, and I'll address them there. And I can even do more videos if that turns out to be something that would help. So, hope this helps. Talk to you later. Bye.